Okay, so hello student. Let us start our today's lecture, which is going to be gravitation. So, gravitation, okay, last time we discussed, as you all know, we were discussing force, right? सबसे पहले हमने मोशन से शुरू किया, मोशन के कॉन्सेप्ट्स हमने किए, एंड देन वी मूव टुवर्ड फोर्स. फोर्स किस तरीके से वर्क करता है, सारी चीजें हमने उसको स्टडी किया. यूनिट्स एंड ऑल सारी चीजें देखते हुए हमने लॉज ऑफ मोशन पे देन स्विच किया, राइट? हमने तीनों लॉज ऑफ मोशन और उनके क्या क्या एप्लीकेशन है, कहाँ कहाँ पे वो एक्ट करते हैं, ये चीजें हमने देखी. देयर आफ्टर एट द एंड वी वर डिस्कसिंग अबाउट conservation of linear momentum. Okay, when two bodies are in motion, so the total momentum before collision as well as total momentum after collision remains the same. So this is called conservation of linear momentum. Okay, so इस चीज को एक बार हम कंप्लीट कर देते हैं, बिकॉज लास्ट टाइम हमने इस स्टेटमेंट को तो देख लिया था कि व्हाट इज दिस कंजर्वेशन ऑफ लीनियर मोमेंटम, which is nothing but, as it says, total momentum before collision, right? Total momentum of the body before the collision and after the collision. Okay, it remains same. Let us understand how. ये मेरी फर्स्ट बॉडी है, ये मेरी सेकंड बॉडी है, इन दोनों का मोमेंटम कोलिजन से पहले और कोलिजन के बाद, यही हमें देखना है, राइट? तो देख लेते हैं. सो आप यहाँ पे खुद देख सकते हैं कि ये मेरा कोलिजन का सिचुएशन है. इसके पहले का टोटल मोमेंटम हम ऐड कर लेते हैं. जैसे कि मोमेंटम कैसे क्या होता है, पहली बात हमें पता होना चाहिए. इट इज मास इनटू वेलोसिटी, राइट? दिस इज आवर लीनियर मोमेंटम. सो टोटल मोमेंटम क्या हो जाएगा इस केस में बॉडीज का? इट विल बी मास ऑफ द फर्स्ट बॉडी एंड वेलोसिटी ऑफ द फर्स्ट बॉडी प्लस mass of the second body plus into momentum of the into velocity of the second body, right? ये दोनों का इनिशियल वाला मोमेंटम हो गया, right? Before the collision. So mass of the first body, velocity of the first body multiplied by multi in the multiplication, and mass of the second body and in multiplication with the velocity of the second body, which is going to be equal to the mass of the first body and the velocity of the first body. Which velocity? Final velocity. So it will become my final momentum of the first body, in addition with mass of the second body and in multiplication with final velocity of the second body. All right, so if it is like that, then can I simply take the body, first body at one side and the second body on the other side? Can I do the same? Yes, I can. So I can see one thing is that here I'm having m1, here also I'm having m1. So let us simply take the total momentum of the first body at one side, which will be m1 u1, right? Initial momentum of the first body, if you take this term on the other side, it will be minus m1 v1, all right, which will be equal to mass of the initial velocity of the first body, right? This will come on the other side, initial velocity of the first body. So I will say m2 v2. This will come on the other side, it will be m2 u2, all right? Okay, so let's take m1 common. It will be u1 minus v1, which is going to be equal to m2. Here it is v2 minus u2, right? So okay, that is there. Then what if I simply multiply the, see what I am trying to tell in this momentum theory? It is saying that total momentum of the body before the collision and total momentum of the body after the collision. But what is the reason behind collision? Okay, and if both are colliding with each other, there is some force acting on the bodies, right? कुछ ऐसा फोर्स है जो दोनों बॉडी पे लग रहा है, बिकॉज ऑफ विच they collided and get separated again and started moving with different velocities. So there is a force acting on the body. This first one is trying to apply some force on the other one, and the second body is also trying to apply some force on the first body. Okay, so the total force of the bodies on each other is equal in magnitude. All right, the forces are equal, no matter if the first body is applying that force or the second body is applying that force. Forces is equal, it is just opposite in direction. How? Let us see the same. So I can write one thing, which is, okay, so yeah, I'll write it like total. Okay, so can I divide my whole term by see, I want to talk about force, right? Force is mass into acceleration. Can I see some similarity over here? I'm having mass, and to make this term acceleration, I need to simply divide it by t, right? Okay, this is what I have to do. So let us first do one thing. Uh, in order to, what is acceleration first of all? It is final velocity minus initial velocity upon change in time. So do I have final velocity over here and initial here? Yes, I have. But here I'm having initial velocity, thereafter I'm having final velocity. So let us first change the things. Okay, let us first simply switch the symbols. So m1 will be here as only. Okay, I need to simply multiply the whole term by minus. I need to simply change the sign. So if it is, if I multiply the whole term by via minus sign, so it will be v1 minus u1, isn't it? Correct, it will be v1 minus u1 because I multiplied the whole term by minus. So it will be minus m1, I mean it will be minus u, and it will be plus v, which is going to be equal to m2 v2 minus u2. Right, now it becomes final velocity minus initial velocity in both the cases. Now I simply have to divide both side by t. Okay, so m1 v1 minus u1 upon t is equals to m2 v2 minus u2 upon t. Okay, all right. So you can see one thing, which is here I'm having mass, minus sign was also there, m1, and this one is my acceleration, a1 is minus, it become m2, this one is acceleration, a2. So can I say the forces are same only? Mass into acceleration is force 1, mass into acceleration is force 2. It is just both are equal in magnitude but opposite in direction. So this sign is trying to tell the same thing, right? The forces are equal in magnitude. The amount is for same of both the forces, but the direction is different. So one is in plus, another one is in minus. Okay, that's it. So this was all about conservation of linear momentum. So we are done with the basics. What we have covered up to now? We have covered up to up to now two topics. The first one is motion. Okay, another one is force, and we saw some laws. Okay, we discussed laws and all those things and its applications. Okay, now we need to move ahead and talk about another important topic called gravitation. Gravitation. So those who are joining this class, so I want to tell you that these topics are the basic ones, right? So here my aim is to simply talk about the basic topics so that you can clear your basics regarding these topics. You must be knowing. So my intention is to let you know the basics of these topics. whether it is motion, force, or gravitation, or any topic. So I'm only covering that part. Okay. So which is important and which is asked in our NDA and CDS exam. So now let's talk about gravitation. Okay. Mhm. So now a new topic, which is the main aim of this lecture, is gravitation. Okay. Right. Okay then. You know what is gravitation, first of all. Everyone knows what is gravitation. It is just the it is just a kind of accelerating force, or it is just a force applied, or it is an attractive force applied by all the heavenly bodies on other bodies, right? Heavenly body means a very big body of a very big size. Like in space, we have Mercury, right? We have Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So these all are heavenly bodies, right? Big, big bodies, and stars, asteroids, and all those things. Everything comes under the heavenly body, which is in the space. Okay. So every object, so let's say sun itself. Sun itself has some gravitational force of itself. Okay. Everybody have a different size of they have different mass, different size. Okay. And they are at a different distance. Okay. So every object in the universe, say your planets or moon or anything, they have their own gravitational force, right? It is not like that the gravity of sun, earth, and every planet is same. No, not at all. It is different for different planets, okay, depending upon their masses and all those things. So there are so many factors because of which the gravity differs, okay, planet to planet. So talking about the same, we know there are four four non-contact, there are forces, right? Forces, we have category of forces. We have contact forces and we have a non-contact forces. So it is very simple, right? As it says itself, contact forces means the force which is exerted only by making a contact. Okay, without making contact it cannot be exerted. तो ऐसा फोर्स जो कांटेक्ट में आने पर ही लगे वो आपका कांटेक्ट हो जाएगा, otherwise the force will be non contact. So can you all give me one example of all the forces, the two forces? Okay, so it can be in contact force, it can be simply the frictional force, right? There is a force called frictional force. So it is simply a contact force. Without making contact, you cannot create friction. All right. Another one could be normal reaction force. Normal reaction force. What is this normal reaction force? Actually, it is nothing but, let us say there is a surface, or there is a block over there, and this block is having some mass. So it is nothing but the overall weight. See, this object is having some weight, okay? It is having some mass and acceleration is being applied on the body. So total weight of the body is acting downward, okay, towards the center of the earth, because earth attracts every object from the center of its, from the core, okay, from the core of earth's core. We we basically experience the gravity on ourselves. That is the reason we are always uh, basically attracted downward, right? And if we simply apply, everybody know one thing is that This mg is nothing but mass into acceleration. Which acceleration? Acceleration due to gravity. And you also know that mass into acceleration is force itself. Correct? It simply means we are basically applying force on the earth. So it is obvious that if we apply some force on somebody, that body applies the equal force on us but in opposite direction. So the normal reaction force is nothing but a force because of the because we are actually applying some force on the earth, and it is the reaction of that force. It is simply the reaction of that force which we are applying. It is same in magnitude but opposite in direction. So normal force is the force which is acted in the opposite direction of the force which we apply on the earth. Okay, it is always perpendicular to the surface. Another force could be okay, so it can be tensile force. What is tensile? Force due to tension. Okay, it is known as tensile force, or you can simply say, what's happening? Force due to tension. Which tension? Tension in a string. Let us say there is some wall or something, right? There is some wall or something. There is an object hanging like this. Okay, an object is hanging like this, and this string is stretched due to the this heavy object. Okay, there is some string and a object is like this. Okay, and this object is having some mass, and so that is the reason the force is applied in the downward direction, the force due to gravity. And this string is having some tension because it is stretched, right? Basically this string is non-elastic. Okay, this string is not going to stretch at all because it is a string which is fixed in length, right? We are not having a rubber or something. So basically it is obvious that if you if you attach some load over here, it will stretch, right? The string will be like this, very much stretched. So this is your tensile force. All these forces I had discussed are contact forces. But if you talk about non-contact one, so it could be non-contact force is nothing but the gravitational force itself. Okay, gravitational force itself. Okay, why? Because see, we don't see anybody pulling us, okay, downward. हमको ऐसा तो नहीं लगता ना कि कोई हमें पकड़ के खींच रहा है. No, it is just something which is invisible. Okay, it doesn't even it seems to be it doesn't actually feel. We don't see anybody pulling us down, right? Because of which you can say it is a non-contact force. It doesn't have an actual contact. It doesn't make actual contact between the two objects, no matter how far the objects are or how close the objects are, no matter their distance is big or small or what, it is always going to be available, right? This force is always present everywhere between the two bodies. Okay, similarly we have nuclear force. Okay, we have nuclear force. Which nuclear force? Strong nuclear force, weak nuclear force. Okay, weak nuclear force. So these are the forces. We also have electrostatic forces. Okay, the force between the two charged particles. Okay, no matter how far they are or how close they are, this force is always present. It is all these forces are non-contact forces. Okay, right. Let's move ahead. So as we are discussing this gravitational force, I want to tell you that the gravitational force. Okay, gravitational force is the weakest force in the nature. Okay, in the nature, the weakest force present is nothing but your gravitational force. Okay, so even if see it, this force is applicable on all the bodies. Okay, no matter whether they are living or non-living. ओके, कोई चीज अगर लिविंग है या नॉन लिविंग है, कैसी भी है, उन सब पे जो है ग्रेविटेशनल फोर्स लगता ही लगता है. इवन इफ यू आर सिटिंग इन अ रूम, राइट, even in your room, the objects lying around you, okay, they are also having some gravitational force. You are also applying some kind of attractive force on them. They are also applying some kind of attractive force. ठीक है, so always remember gravitational force is always attractive in nature. Attractive in nature. Gravitational force is always attractive in nature. Okay, correct. So it is like that, and it is the weakest force, as I said. So no matter, even if we take, we let us say there are two friends walking beside each other. So the two friends are also having some kind of attractive force between them. That is nothing but a gravitational force. And even if you're sitting in at a different place, and your home is at different place, then also you, if I consider the two bodies, you and your home, both are having some kind of attractive force with each other. Okay, both are applying attractive force on each other, but it is so weak, right? It is so small, weak, that it doesn't even feels. हमको वो बिल्कुल फील भी नहीं होता है. चलो, तो आगे बढ़ते हैं. Right. So force are attracting the object to Earth's center. In simple terms, I can say, what is gravitational force? What is gravitational force? I will say the force attracting object to Earth's center. It is that kind of force which attracts all the object towards Earth's center. Okay. What about see, Newton also gave one theory, right, on the gravitational force itself. Everybody knows the story behind the apple and apple tree, right? There was an apple tree. Okay, apple was here, and Newton was sitting somewhere here. Okay, he saw apple, that one day ये जो एप्पल था आपका, वो टूट के गिर गया. ठीक है, टूट के गिर गया, ये स्टोरी सबने सुनी है. तो अगर ये एप्पल टूट के गिर गया, तो इसके पीछे ही then and only then started pondering upon the same topic. Okay, he, it seems very obvious that, like कि इसमें सोचने वाली बात क्या है, but he was that boy person who simply thought about this thing कि क्यों चीजें नीचे ही क्यों गिरती हैं, क्यों ये एप्पल नीचे ही गिर गया, हम सब नीचे की तरफ क्यों अट्रैक्टेड होते हैं. देन एंड देयर ही स्टार्टेड थिंकिंग अबाउट द सेम. सो चलो जल्दी से हम न्यूटन के लॉ की बात कर लेते हैं, या फिर उनका क्या ऑब्जर्वेशन था अबाउट प्लैनेट्स एंड ऑल दोस थिंग्स. तो हमारे जो न्यूटन थे, न्यूटन के कुछ ऑब्जर्वेशन रहे. ठीक है, देयर वाज सम ऑब्जर्वेशंस. सो लेट अस राइट ऑब्जर्वेशन अबाउट planet. What were the observation done by Newton on planet? Observation about planets. ओके, आज पहले लोगों को लगता था कि दुनिया फ्लैट है, राइट, बट लेटर when our great scientist Aryabhatta and all those when came, So they simply said, no, world is not flat, it is rounded, okay? It is spherical. It is spherical in shape and it revolves around the a very big object called sun. Initially, people used to think that sun revolves around the earth, but the case was opposite. Okay, so these things were explained by different people. So what was the Newton's observation about the planet? The first observation was that revolution of moon around earth, right? These observation he made. He also तो उन्होंने सीधा सीधा बताया कि जो आपका मून है वो किस तरीके से रिवॉल्व करता है. रेवोल्यूशन ऑफ मून अराउंड द अर्थ. ओके, देन second thing is revolution of moon around the earth, then planets around sun. He also discussed about the planets which are revolving around the sun, and then they also talked about the objects coming towards the earth. ओके, अर्थ की तरफ जो ऑब्जेक्ट्स आ रहे हैं उनके बारे में भी उन्होंने बात किया, एस्ट्रॉइड, मीटियोराइट्स एंड ऑल दोस थिंग्स. ओके, फाइन देन. So, what was the sequence or chronology? See, there were different people who gave different concepts, right? So, गैलीलियो, एक हमारे फिजिसिस्ट थे, आपने सुना होगा कभी ना कभी, गैलीलियो गैलीली. ठीक है, तो गैलीलियो गैलीली ऑल्सो गेव सम कंसेप्ट. ओके, उन्होंने बताया कि बेसिकली आप किसी भी चीज को अगर आपने अगर कंटिन्यूस, यहाँ पे उन्होंने न्यूटन के सीधे सीधे लॉ की बात की थी, राइट? एवरी ऑब्जेक्ट, वो जो हमने लास्ट टाइम हमने बात किया था वहां पे भी उनका कोई कंट्रीब्यूशन था. सो ही सेड कि सारी ऑब्जेक्ट्स जो हैं उनको अगर किसी लेटस से अगर वो ऑलरेडी एक्सेलरेशन मोड में है, दे आर ऑलरेडी मूविंग. ओके, कोई ऑब्जेक्ट अगर कंटिन्यू मूव कर रहा है तो वो कंटिन्यू ही मूव करता रहेगा. ओके, there is no need of applying force on that body in order to keep it moving. Okay, so न्यूटन ने कुछ कुछ पहले के लोगों ने क्या बताया था कि अगर हमें एक ऑब्जेक्ट को कंटिन्यूअसली मोशन में रखना है, लेट अस से आप साइकिल चला रहे हो, ठीक है, यू आर राइडिंग अ सिंपली बाईसाइकिल, आप साइकिल जो है चला रहे हो. ओके, तो जब आप साइकिल चलाते हो तो आप बहुत देर तक पेडल मारते मारते फिर आपकी जो साइकिल है वो उसके पास एक अच्छी वेलोसिटी आ जाती है. ठीक है, वो अपने आप चलती रहती है. आप पेडलिंग करना बंद करते हो फिर भी चलती रहती है, चलती रहती है, चलती रहती है. धीरे धीरे उसकी स्पीड कम होती है, राइट? फिर से आपने पेडल देना पड़ता है, राइट? क्यों? क्योंकि आपकी स्पीड कम हो रही है. तो इन ऑर्डर टू कीप योर सेल्फ मूविंग, आप सोचते हो कि चलो फिर से पेडलिंग करते हैं वरना गिर जाएंगे. बट इन्होंने क्या कहा था, गैलीलियो ने ये कह रहे थे कि नहीं नहीं, कोई जरूरत नहीं है. अगर एक ऑब्जेक्ट को मूव कराते रहना है तो अगर वो ऑलरेडी मूव कर रहा है तो हमें कोई जरूरत नहीं है उसको दोबारा पेडलिंग करने की, दोबारा धक्के लगाने की, दोबारा फोर्स लगाने की जरूरत नहीं है. वो हमेशा के लिए वो मूव करता रहेगा. हम्म तो यानी कि सुनने में तो ये बात गलत लग रही है, राइट? सुनने में तो ऐसा लग रहा है कि भाई ये तो साफ साफ गलत बात है, बट ऐसा नहीं है, ये बिल्कुल सही बात है. गैलीलियो ने जो कहा था बिल्कुल सही कहा था. क्यों कहा था ऐसा सही? क्योंकि जो साइकिल का मैंने आपको बता दिया, राइट, साइकिल का जो एग्जांपल दिया मैंने, तो साइकिल पहले तो स्पीड ज्यादा होती है, पैडलिंग करते बंद पैडलिंग बंद करते हैं तो धीरे धीरे साइकिल स्टॉप होती है. ओके, ये हो क्यों रहा है? दिस इज ऑल बिकॉज ऑफ द फ्रिक्शनल फोर्स. ओके, हमारी जो धरती के पास जो हमारी जो लैंड है, दिस दिस फ्लोर और द ओके रोड, जिस रोड पे साइकिल चल रही है वो तो बहुत ही ज्यादा रफ है ना, बिकॉज ऑफ विच देर इज अ ह्यूज फ्रिक्शन एक्टिंग ऑन द बॉडी. This is the reason it is reducing its velocity, or you can simply say the acceleration. Okay, so if we simply remove the friction, if we take a surface which is so smooth, it is so smooth that let us say the frictional force is negligible. Okay, let us say you are having a surface whose frictional force is negligible, it is almost zero. In that case, your body will never stop at all. If you apply some force on the body, why would it stop? It will never stop because there is no friction at all. It will keep on going and going and going forever. Okay, it is like that. So it is all because of the friction, because of which we need to apply force again and again. So these were some observations done by these scientists, and they come to some conclusions. Let us simply discuss them. तो कुछ बातें तो मैंने आपको बता दी, जैसे कि रेवोल्यूशन, ये सारी बातें इन्होंने गैलीलियो ने भी डिस्कस की, और इन्हीं को मॉडिफाई करके लॉ बना दिया गया, किसके द्वारा? बाय न्यूटन. ओके, न्यूटन से पहले हमारे गैलीलियो साहब आ गए थे, उन्होंने कुछ कुछ थ्योरी दिया, और उसी को मॉडिफाई करके हमारे न्यूटन सर ने क्या कर दिया? लॉ बना डाले, उनकी थ्योरी को पढ़ के. तो आगे देखते हैं. तो जिस फोर्स ऑफ अट्रैक्शन से आपकी अर्थ हर चीज को खींचती है, उसको ग्रेविटेशनल फोर्स कहते हैं. सिंपल, लिखने की कोई जरूरत नहीं है. एंड द फोर्स एक्टिंग, सपोज अगर आपका जो सर एक कोई ऑब्जेक्ट है. ओके, देयर इज अ ऑब्जेक्ट विच इज रिवॉल्विंग इन अ सर्कुलर फॉर्मेट. ओके, कोई चीज अगर गोल गोल घूम रही है, लेट अस से कोई चीज अगर गोल गोल घूमती है, तो कोई चीज सर्कुलर स्ट्रेट लाइन को छोड़ के सर्कुलर मोशन में कोई चीज क्यों आ जाती है? राइट, इट इज बिकॉज सर्कुलर, अगर कोई चीज स्ट्रेट लाइन में है तो वहां पे सेंट्रीपिटल फोर्स नहीं होता. ठीक है, देयर इज नो सेंट्रीपिटल फोर्स इन व्हेन द बॉडी इज इन स्ट्रेट लाइन. सो इफ द बॉडी इज इन मोशन, if the let us say I'm having an object, this object is in motion. Okay, the object is revolving like this continuously. So whenever the object is in circular motion, there is some kind of force acting on that body towards the center, at each and every point, isn't it? There is some kind of force acting on the object at each and every point. Okay, so this force basically, yes, we all know that this force is gravitational force, huh? Because of which the things are continuously revolving around a particular body. And this is also basically the force of attraction here is gravitational force, because of which everything is being attracted towards the center of the earth. And the force acting in a circular object, when a body is in circular orbit, the reason behind being in a circular orbit is that there is a force called as gravitational centripetal force. Okay, there is a force called centripetal force, because of which all the objects are revolving in a circular motion. If all the objects are revolving in a circular motion, that means the object is it simply means that there is some centripetal forces being applied on the body. Okay, let's move ahead. Okay, so force acting in a the force acting in a circular motion is called centripetal force. Okay. All right. Now let's uh, let's talk about the gravitational force and the universal law of gravitation. Okay. Okay. One more thing I would like to tell you is that whenever the body is in centripetal under the centripetal force, what is first of all what is the formula of centripetal force? It is mv square upon r. Okay, it is mv square upon r. You can also write it like m omega square r. Okay, this is also the formula. Both are the formula of centripetal forces. And centripetal acceleration is v square upon r, or you can say omega square r. This is your centripetal acceleration. So whenever the body is under the centripetal acceleration, आप बोलोगे कि change the velocity. So it basically changes the velocity at every point. Okay, to keep it accelerating. Okay, to keep the acceleration. Uh, basically, you can simply write. You can even imagine, right? How? लेट अस से एक ऑब्जेक्ट है वो सर्कुलर पाथ पे बार बार घूमते जा रहा है. हम्म, ऐसा क्यों हो रहा है? क्योंकि अंदर से सेंट्रीपिटल फोर्स कंटिन्यूअसली लग रहा है ना. और बिकॉज सेंट्रीपिटल फोर्स जब कंटिन्यूअसली लगता है तो क्या होता है, जो ऑब्जेक्ट है वो क्या करता है, सी उस ऑब्जेक्ट का एट एवरी पॉइंट डायरेक्शन चेंज होता है. ये बात ध्यान रखना. जब बॉडी सर्कुलर मोशन में होती है तो ईच एंड एवरी पॉइंट क्या होता है, डायरेक्शन में चेंज आता हुआ हमें नजर आता है. ओके, करेक्ट. ये बात हमें समझ आ गई. देन हम्म ओके, सो वन मोर थिंग इज दैट just write it down that change under the centripetal force, there is a change. It changes the velocity. Okay, also this is because when there will be a change in velocity, then and only then there will be acceleration. Okay, so to keep the acceleration. ओके, आगे बढ़ते हैं. ग्रेविटेशनल फोर्स को जो है कहाँ कहाँ देखने मिलता है आपको पता है, सन अर्थ और मून के ऊपर. और यूनिवर्सल लॉ ऑफ ग्रेविटेशन की हम बात कर लेते हैं. लेट्स टॉक अबाउट वेरी इंपॉर्टेंट थिंग कॉल्ड यूनिवर्सल लॉ ऑफ ग्रेविटेशन. ओके, so the universal law of gravitation says, right, so no matter where, okay, in the entire universe, no matter you are talking about this particle or that particle, okay, any particle, no matter how what is the distance between the two particles, how far the particle is, what is the mass of that object, and everything. Okay, so you all know that I already told you the gravitational force. Okay, I already told you that the gravitational force is is the range is infinite. Okay, the range of the gravitational force is infinite. It is a very long range. Okay, it is simply the infinite. No matter how far the object is, it can still apply the gravitational force on one body to another. Okay, so gravitational force is simply The universal of gravitation is simply says that the two objects, which no matter how far or close they are, right? The gravitational force between the two bodies, okay, it is directly proportional to the product of the masses, okay, and inversely proportional to the square of the radius between them. Simple, right? चलो हम बात करते हैं इसकी. All object in the universe attract each other. First of all, I like to tell you, okay, just write it down. All object in the universe attract all object in the universe attract sorry each other. Second, force of attraction is directly proportional to the product of masses. In simple terms, otherwise you can write the full length derivation, full length definition, okay? So we don't need to write it completely, we can do the same in short form. So all objects in the universe attract each other. Another one is force of attraction. Force of attraction between the bodies is directly proportional to the product of the masses. Product of the masses, and you can say force of attraction is inversely proportional to the square of the distance, okay, is inversely proportional to the square of the distance between them, okay, which means the force of gravitation is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. All right, correct. So it is like that. See, if I'm having these two objects, there is a distance. See, from the center of the two bodies, from the center of the first body M1 and second body M2. So gravitational force is always a central force. Okay, it acts on another body from the center. Correct? So you can say the gravitational force is the basically product of the masses. And if you increase the distance, force will be reduced, right? So it is like that. So आप क्या बोलेंगे जब आप यहाँ प्रोपोर्शनल का साइन हटाएंगे इज इक्वल टू रखेंगे, so you will get a gravitational constant capital G. Okay, you will get a gravitational constant capital G. So आपको पता है ये जो आपका G है, ये जो gravitational constant G है, this G is simply a constant whose value is, this is called, you can simply say, gravitational constant whose value is 6.673 into 10 raised to the power minus 11 न्यूटन मीटर स्क्वायर पर केजी स्क्वायर. ओके, करेक्ट. अब हम देखते हैं, यहाँ पे आप सीधा सीधा पुट करके आप आंसर निकाल सकते हैं, जिसका मतलब क्या है, देखो ये इनवर्सली प्रोपोर्शनल है, मतलब इफ यू इंक्रीज द रेडियस और इफ बेसिकली डिस्टेंस, द फोर्स विल बी रिड्यूस्ड. ओके, the force will be reduced. But okay then. This was about, you know what is M1, M2, mass of the first and the second bodies respectively, and your F is the gravitational force. Okay, that's it. तो ये वाला हमने हमने डेरिवेशन तो कर लिया है. आगे हम इसी ग्रेविटेशनल लॉ के आगे प्रोसीड करते हुए we will discuss about Kepler's law. Okay, Kepler's law of planetary motion, because here we are talking about forces between the planets and all those things, heavenly bodies. So now we have to discuss that there was a again physicist called Kepler. Okay, so you all know that we have Galileo's contribution in all those laws, right? We have Newton's contribution, Galileo's contribution, and Kepler's contribution. And before all of them, there was a Indian sage, Aryabhatta, okay, who simply told about all these things way before in the beginning of the, or you can say in the 500 AD itself, around 500 AD itself. So we Indians were way ahead, but the thing is that they simply, we in today's world we know about these three people most of the time. Okay, we talk about them. So the Kepler, who was Kepler? So after Newton, after Galileo, a person called Kepler came and he again observed, but very briefly, very descriptive way में, he simply observed the heavenly bodies and derived three laws, important laws, very interesting ones. Okay, so it would have taken a lot of efforts, like, you know, हमारे साइंटिस्ट जो ये लॉज निकालते हैं, इनके पीछे उनकी पूरी जिंदगी मतलब खर्च हो जाती है, राइट? ये पूरी जिंदगी इनमें लगे रहते हैं. सो वी नीड टू अगेन थैंक देम. बट लेट्स कीप ऑल दिस थिंग असाइड and talk about Kepler. Kepler was a physicist who again talked about the planetary motion. We have Kepler's laws of for planetary motion. ओके, सो ये हमारे केपलर साहब ने अगेन थ्री लॉ को इंट्रोड्यूस किया. पहला लॉ ये बताया कि हमको आज तक लगता था कि इस दुनिया में सब चीजें गोल गोल घूमती हैं, राइट? आज तक तो हमें यही लगता आ रहा था कि दुनिया में ये वो भी ठीक है, गोल गोल घूमती इन द सेंस जो हमारे प्लैनेट्स हैं, ओके, वो बिल्कुल सन के अराउंड एकदम सर्कल में घूमते होंगे, प्रॉपर सर्कल. ओके, पहला भ्रम तो हमारा ये था कि एकदम सर्कुलर ऑर्बिट में रिवॉल्व करते होंगे, बल्कि ऐसा बिल्कुल भी नहीं था. केपलर ने जब स्टडी किया अच्छी तरीके से, सो ही गॉट टू नो दैट हमारी जो सन है, सन के आसपास प्लेनेट बिल्कुल सर्कुलर वे में रिवॉल्व नहीं करते हैं, जबकि ये ओवलिक शेप में रिवॉल्व करते हैं. ओके, ये हमको समझ में आया. ओवलिक शेप में जो है रिवॉल्व करते हैं, तो ऐसा ये बताया गया. हाउ हाउ कम? सो सी, ये चीज कैसे पॉसिबल हुई, कैसे ओवलिक शेप में रिवॉल्व करते हैं? तो दिस इज ऑल बिकॉज ऑफ द दिस इज हाउ द प्लैनेट्स एक्चुअली रिवॉल्व. आज तक हमें यही पता था कि सर्कुलर मोशन में रिवॉल्व करते हैं, तो पहली मिथ तो उन्होंने ये सॉल्व किया. सेकेंडली ही टॉक्ड अबाउट देयर थ्री लॉज आर नोन एज लॉ ऑफ एरिया, लॉ ऑफ ऑर्बिट एंड लॉ ऑफ बेसिकली पीरियड. ओके, सो इन्होंने ये भी बताया कि प्लैनेट एक पर्टिकुलर टाइम में कितना डिस्टेंस, जो कितना एरिया स्वैप कर लेते हैं, अगर वही पर्टिकुलर टाइम में दूसरी जगह पे होंगे, उतने टाइम में सेम उतना ही एरिया को वो जो है स्वाइप करेंगे, स्लाइड करेंगे. ओके, तो ये कुछ बातें थी. थर्ड लॉ वाज ऑल अबाउट पीरियड, मींस टाइम, कि एक प्लेनेट को सन के आसपास चक्कर लगाने में कितना टाइम लगता है, और उनका डिस्टेंस और टाइम का क्या संबंध होता है, क्या आपस में रिलेशन होता है। ओके, डिस्टेंस एंड टाइम का आपस में उनको रिलेशन देखना था, टाइम एंड डिस्टेंस। ओके, तो ये चीजें भी उन्होंने देखा। ही सेड स्क्वायर ऑफ द टाइम इज डायरेक्टली प्रोपोर्शनल टू द क्यूब ऑफ द रेडियस, एंड दिस वाज एब्सोल्युटली करेक्ट है। इस चीज को जब वाकई में ऑब्जर्व किया गया तो पीपल वर सरप्राइज्ड टू नो that how it is actually working. So it is like that. So we have again three laws which which we will discuss tomorrow, because because again we will be having this discussion on Kepler's law of planetary motion, because we discussed some basic things regarding gravitation today, right? Some forces, types of forces, contact, non-contact forces, right? And we did our yesterday's topic, which was conservation of linear momentum. तो आज के लिए इतना काफी है, ठीक है। कल हम यहीं से स्टार्ट करते हैं, केपलर्स लॉ ऑफ प्लेनेटरी मोशन को कंटिन्यू करते हुए। थैंक्स अलॉट। ओके, सी यू टुमारो।